Hello everyone and welcome to yet another problem from Geeks for Geeks. The problem is pretty simple. It says segregate zeros and ones. The gist of problem is we are given an array containing only zeros and ones, and we need to modify array in place to segregate zeros to the left side and ones to the right side of the array. So that's pretty simple. And we are expected to do within O of n time complexity, O of 1 space complexity. That's cool. So there are pretty much obvious solutions. One thing is we can go ahead and sort this array. Obviously sorting would give us the required output. Second one, but this doesn't consume a good amount of space. It will take a good amount of time. It will take O of n square time complexity. And yeah, post which we can have a counters which will count zeros and ones. So it will take O of 1 time complexity, n time complexity, and O of 1 space complexity, which would satisfy our condition. But we will have 2.2 variables which would be storing the number of zeros and count of ones, or which we can boil down to count of 0. Basically, if we have count of 0, we'll have count of 1 as arr.size or length minus count 0. Let's make it a for simplicity. Cool. Not only this, but we also have a third way which can be done in place by swapping. We will be discussing all threes one by one. Sorting will not be discussing because it's quite simple. You can go ahead and you can have it sort, which is not even efficient. So let's take approach 2. So I'll say counter based implementation. We'll implement this using a counter, and I'll just send a over here, and we'll have just like void method, which will take an array a. We'll have a count, or if I can take this itself, okay. And I'll just go ahead and iterate from int I is equal to 0, I is less than a dot length, and I plus plus, for which I'll maintain a count 0 plus equals to a of I is equal to 0. Then I'll increment the count by 1, else I'll just make it increment the count by 0. Postage, this is counting loop, and now we want a setting loop. So for int I is equal to 0, or I'll just say for int I is equal to 0 here, and while we have count 0 is greater than 0. Till this moment we wanted to go ahead and set zeros from I to whatever location we are reaching to. So I'll say a of I plus plus is equal to 0. So I'll count is 0, then we set this number a with a of I plus plus equals to 0. Now we need to decrement the count by 1. Makes sense? We have set 0, now it's time to set 1. So while I is less than a dot length, we'll set 1. A of I plus plus equals to 1. And that's it. We have setting loop, we have counting loop, and we have did our job. Let's check this one. Yeah, it's working fine. Let's check with rest of test cases as well. It's taking a while. Well, it seems it has passed rest of test cases as well, but we are not stopping over here. Let's see what is the third in place swapping implementation is. So I'll say in place, I'll say A. Cool. And I'll just go ahead and write a method void in place. Let's remove this and let's take int array, and we are going to do in place. So what's the logic behind in place? So you see, what was the drawback? We were iterating first time the array once, then we were setting one by one the countings as per the countings 0 and 1 respectively. So it takes 2 loops at least. In this case it takes 3 loops, but it takes entire 2 times traversal of an array. So can we mitigate that? It seems yes. So the gist of the problem lies here, that 0 needs to be first and 1 needs to be at last. So why don't we do one thing, that we set 0 at 0's place and 1 at 1's place. For that we need to know the places. So let's 0 iterator, which will give us the current position where 0 should be inserted, which would be 0 initially because it's the first position, and we'll have a 1 iterator, which is a.length minus 1. Both of them are valid indexes because we don't want to put any number, maybe 0 or 1, within any of the invalid indexes. So keeping that in mind, so let's traverse one by one. So int, or for simplicity I'll take just a while loop, I is less than a.length, or I'll just say I is less than 1 iterator, because 1 iterator is a.length and 1 seems to be the ending positions. It will lower the number of iterations or number of traversals for the loop iterations. But what is I? I is a simple variable which we'll use for iteration purposes. So in this time we'll take I is equal to 0 and we'll say if a of I is equal to 0, it's time to insert the number into 0 position. Now we need to, a of I is equal to 0. So 0th position we are setting it, so we'll say a of zero iterator is equal to 0 and 0 iterator plus plus. Else, if you found 1 over this place, found 1, then we will set this one at the end. So we'll say a of 1 iterator is equal to 1, but doing so we will lose the value at iterator 1. So let's copy that value. So int value at last, or I'll just say value for simplicity, it denotes the value at ending, is equal to a of 1 itr, and let's save this value to current location. A of I is equal to value. Cool, makes sense. And here we'll say 1 iterator minus minus. Why minus minus? Because we have already used this position, so next preceding 1 could be into this location. So 1 minus minus, the 1 iterator would go towards 0 and the 0 iterator would go towards length. Make sense? and if next time if 0 founds or 1 founds, it will set its positions till the moment I is less than 1 iterator, and we are good to go. Also we are incrementing I iterator over here. We don't want the loop to be running infinitely, so yeah. So let's compile this to check against sample test cases. It runs fine. Let's check with the rest of test cases as well. It kind of runs faster. It has stuck. Cool. So it has ran well, it seems. So that's it. That's about it. There are 2 ways, technically 3. We are not counting the first one over here, both of which were within O of n and 1 complexity. The companies have been asked in was Paytm, Goldmann Sachs, and Fab.com. So that's all about it. And if you wanted to see more such awesome content, click the video on the right, and I'll see you in the next one.